Mount St. Helens and Yellowstone are two of the most well-known volcanoes in the United States. They have some pretty obvious differences, but they have some similarities as well, and what we learned at one volcano, we can apply to the other. May is Volcano Awareness Month in the state of Washington, so let's ask the question, just how similar are Mount St. Helens and Yellowstone? Now, of course, these two systems have very different origins. Yellowstone is fed by a deep mantle hotspot where there's a stationary zone of melting and the North American tectonic plate drifts over the top of it, and you get a chain of volcanoes. The Yellowstone system is the youngest of those volcanoes, but they stretch across southern Idaho. At Mount St. Helens, there are two plates that are interacting. The Pacific plate is diving down beneath the North American plate. That generates magma that feeds the Cascades. Now, both volcanoes have very complex magmatic systems. There's sort of a heat engine deep beneath both that provides enough energy to melt rock and form these silica-rich magma chambers a few miles beneath the surface. Because they're rich in silica, these can hold a lot of gases in them, and they tend to be a bit more explosive. Of course, Mount St. Helens is the most explosive volcano in the Cascade Range, and I don't think we need to talk about Yellowstone's great explosive potential, right? But what's also common to both volcanoes is that they erupt lava more than they explode. Lava flows are very common at Mount St. Helens. That's what gave us the edifice that we see today, and we saw a lot of lava flow activity from 1980 to 86 after the big explosive eruption there, and also from 2004 to 2008. And in fact, lava flow activity at Yellowstone occurred several dozen times since the big eruption that formed Yellowstone caldera about 631,000 years ago. The differences between the two systems are really mostly related to scale. The big explosive eruptions at Yellowstone are 100 to 1,000 times bigger than those from Mount St. Helens. You can find thick deposits of Yellowstone ash from Kansas to southern New Mexico to offshore of Northern California. Whereas the Mount St. Helens deposit, while they covered a fair amount of area, were relatively thin and were only thick close to the volcano in a relatively narrow band just off to the east. The lava flows at Yellowstone are also much bigger, 100 times bigger than the kinds of flows we see at Mount St. Helens. The size of Yellowstone also dwarfs Mount St. Helens. You could fit about 25 Mount St. Helenses inside Yellowstone caldera. And of course, the magma system at Yellowstone is orders of magnitude bigger, although fortunately mostly solid. While Yellowstone is definitely the bigger system, Mount St. Helens is certainly younger. The last big explosive eruption at Yellowstone that formed the caldera there was 631,000 years ago, and the last lava flow was 70,000 years ago. Whereas Mount St. Helens, the mountain that we know today, didn't even form until about 4,000 years ago. Both volcanoes also host hydrothermal systems. There's a lot of hot water circulating just beneath the ground, and you can see this on cold mornings in both places by all the steam that's rising. But at Yellowstone, you've got a huge volume of water, a really large heat engine, and the geology is just right for forming lots of conduits for hot water to flow through. And that's why you get thousands of thermal features, geysers, hot springs, mud pots, fumaroles at places like Yellowstone, whereas at Mount St. Helens, you really just have a few gas vents. Now, speaking of geysers, Steamboat Geyser, the tallest active geyser in the world, had an eruption in Yellowstone in the month of April. So let's go back and look at the month that was, talking about seismicity, geyser activity, and ground deformation.
Yellowstone monitoring data indicated background levels of activity during the month of April, and that includes seismicity. During the month, the University of Utah seismograph stations located 152 earthquakes. The vast majority of them, as usual, are in this band between Hebgen Lake and extending into the north-central part of Yellowstone National Park. There were 2 swarms in the month, also in this region. 19 events occurred toward the end of April, just north of West Yellowstone. And then there's a larger swarm that's ongoing as of the end of the month. 86 events so far, a little bit to the north-northeast of that swarm. And this one includes the largest event of the month, which is a magnitude 3.1 that occurred on April 23rd. This is vertical deformation at the White Lake GPS station on the east side of the caldera. Each one of these blue dots is 1 day of data. Upward trends indicate uplift, and downward trends indicate subsidence. And over the past 2 years, we're seeing a continuation of trends that have been ongoing since 2015. That is, overall subsidence with an interruption in that, pause or a little bit of uplift during the summer months due to changes in groundwater conditions. Since September, we've had subsidence of a few centimeters, about an inch or so over that time frame, so really no changes in the style of ground deformation. And finally, looking at activity at the largest geyser in the world, that's Steamboat Geyser in Norris Geyser Basin. Started the month with some minor activity, as you can see in this temperature plot. This is measuring temperature in the outflow channel for the geyser. It culminated in a major eruption, the second major of the year, on April 3rd. After that, the geyser basically went dormant. We see just temperature variations related to daily temperature fluctuations, and then towards the end of the month, we started getting minor activity again. So this is a sign that we're probably headed towards another major eruption of the geyser sometime during the month of May.
Well, that does it for the May 1st, 2024 Yellowstone Volcano Observatory Monthly Update. Please remember to hit like and subscribe down below, and if you have any questions,